This is systems of equations with 3 variables. So this is the problem. The first step you have to do is get rid of one of the variables. Luckily enough for us, y gets out easily. So we cross out one of the equations and use these two to make a different equation. So this one, the y cancel out to make that right there. And then we cross out this one, and again the y cancels out to make the second one down here. Since no of these two variables cancels out easily, I multiply the top one by -3 and bottom one by 2 to give us these two equations. And from here, the x's cancel out, giving us 2z is, then we add them together, giving us -2z is equal to 6. Divide that by -2. First problem, z is equal to -3. So then with this, we're going to plug z back into this one right here to give us this. So plug -3 back into where z was, is -12, add 12 to both sides. 2x is equal to 8, divide by 2, and x is equal to 4. So then we're going to be putting these two, x and z, back into the original, or one of the original equations, which I use the top one. So plug x back in, x is 4, 4 minus y, minus 3, which is z, is equal to -1. So add 3 to both sides, we get this. Then subtract 4 from both sides, we have this, and then divide by -1, and y equals 2. And there is your answer. I have 2 practice problems. This is the first one. Pause it now so you can solve it.
The equation for finite vector series is s of n equals a1
Alright, and these are the answers.
to the n power all over 1 minus r.
Alright, second problem. Pause it now if you want to solve. And these are the answers.
Systems of inequalities. So we got -x plus y is greater than -1, and x plus y is greater than 3. -x plus y is greater than 1, therefore y is greater than x minus 1. And so you graph it, plug in a point. I put -2 and 2, and that did not work. So I plugged in 1 and 1, and that worked, so I shaded that side. And then for the other equation, I did y is greater than 3 minus x, so I plugged in 1 and 1, and that did not work, so I did not shade that side. And I plugged in 2 and 2, and that did work, so I shaded that side. And then for the last part, I shaded with both colors the side that they both were in, and just that side because it was just this one, and just red because it was just like that.
So these are boat and current word problems. So the first problem is it required 4 hours for a 50-kilometer boat trip and 5 hours for the return trip against the same current. What would have been the rate of the current, rate without the current? So you want to use the distance equals rate times time equation here. So the first thing you would do is with the current, you would have 500 kilometers equals the rate times the 4 hours that it takes to go with the current, and you would get the rate as 125. And then without the current, you would take 500 kilometers equals 5 hours without the current times the rate, which would equal 100. After that, you would use s as the speed of just the boat without the current, and then c as the rate of the current. So s plus c would equal 25, which was your rate with the current, and then s minus c would equal 100, which was your rate without the current. You make this equation equal s, so it would be s equals c plus 100, and then you plug it into this equation. So it would be s plus 100, or c plus 100 plus c equals 125. Then you keep on going to get c to equal 12.5, and so that's your rate of the current. And then you want to plug c back into one of these two equations, and I plugged it into this equation, and the speed of the boat would be 112.5. So these are practice problems, and if you want to do these problems, then you can pause it right here. And then here's your work, and your answers are right here. And then this is another practice problem, and if you want to work on it, pause the video. And then here is your work, and here are the answers.
Here's a practice problem. You can pause the video and do it by yourself if you want. And there are your answers. Thank you for watching, and yes. Investment problems. Last year, Zach received $469.75 interest from two investments. The interest rates on one was 7.5% and 8% on the other. Total amount invested was $6,000. How much was invested at each rate? So you've got x plus y equals 6,000. X and y are the amounts in each account. So you do 0.075x plus 0.8y equals 469.75, and so you subtract 0.75x plus 0.75y to cancel out the x's, and you get 0.005y equals 19.75. So y equals 3950. X plus 3950 has to equal 6,000. So x equals 250. At 8%, therefore, there was $3,950 invested, and at 7.5%, there was $2,550 invested.
This is how to solve systems of equations with quadratics. So this is the problem. First, what we're going to do is set these equal to each other, because it's y, whatever. So you get x minus 2 is equal to x squared minus 4x plus 2, or minus 2. Add 2 to both sides and subtract x from both sides. And you have x squared minus 5x. Factor out an x, and you get x times x minus 5 equal to 0. And if you set those equal to 0, you get x values to be 0 and 5. To get the y values, we plug these x values back up into this equation. So we got y equals 0 minus 2, and y is equal to 5 minus 2. So our y values would be negative 2 and 3. So our points for the intersection, or the answers, would be 0, negative 2, and 5, 3. And next we're going to find the distance using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, and the square root of that. So 5 minus 0 squared would be 5, and 3 plus 2 squared would be 25, both these, sorry. And then, so it comes out to the square root of 50. Simplify that, you get 5 root 2, and that is it. Alright, so these are the practice problems for systems of equations using parabolas and lines. The first problem is y is equal to negative 2x plus 3, and y is equal to x squared minus 6x plus 3. Pause it now if you want to solve. So the points are 0, 3, and 4, negative 5, and the distance is 4 root 5. Second problem is y is equal to x squared plus 1, and y is equal to x plus 1. Pause now if you want to solve it. The points are 0 and 1, and 1 and 2, and the distance is the square root of 2.
This is linear programming. Linear programming is a method of finding a maximum or minimum value of an objective function that satisfies a given set of conditions called constraints. A constraint is one of the inequalities in a linear programming problem. The solution to the set of constraints can be graphed as a feasible region. The max or minimum values occur at vertices or corner points of the region. The steps are using equations, graphs, then finding the vertices, and then substituting. Here's your first problem. A tray of chocolate chip cookies requires 4 cups of milk and 3 cups of flour. A tray of sugar cookies requires 2 cups of milk and 3 cups of flour. There are 16 cups of milk and 15 cups of flour available. The baker makes $4 profit per tray of chocolate chips cookies and $3 profit per tray of sugar cookies. How many trays of each should the baker make in order to maximize the profits? So, you let x equals the chocolate chip cookies and let y equal the sugar cookies. First you want to find the constraints. So you would do 4x, which is the 4 cups of milk, and 2y, which is the 2 cups of milk, and you have 16 cups of milk. So it would be that equation. And then you have 3x because of 3 cups of flour, then 3y because of 3 cups of flour for this one, and then the most you have is 15 cups, so this would be your equation. Then you want to simplify your equations and substitute them into each other. So those are your 2 equations. Next, you want to graph the equations, and you would get this graph. You want to find the vertices, and that's the points that they're shaded, that they hit shaded in. So you get 0, 0 as the first one, then 0, 5, 4, 0, and 3, 2. Your profit equation would be 4x plus 3y because you make $4 profit per chocolate chip cookies and $3 profit per sugar cookies. After that, you want to plug in your equation or your vertices to your equation. So you get 15, 0, 16, and 18. Since 18 is the highest amount you get, you want 3 trays of chocolate chip cookies and 2 trays of sugar cookies. Here's a you-try problem. A loaf of cornbread requires 4 cups of flour and 1 cup of sugar. A loaf of banana bread uses 2 cups of flour and 1 cup of sugar. Chloe has 16 cups of flour and 7 cups of sugar. She makes $2 profit per loaf of cornbread and $3 profit per loaf of banana bread. To maximize profits, how many loaves of bread each should she make if she must make some of each? Remember the must make some of each. Pause it here if you want to do this problem. Here's the answer to your problem, and here's all the work.